Okay. Hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester B.sc physics honors BCS model. In our last class we have been discussed this question belongs to Lorentz series, that is your find Lorentz series of 1 by z into z minus 1 about z0 equal to 1. So here first we done the partial fraction. This is the partial fraction, and separately we found the Lorentz series of this one and this one. Okay, in detail we have been discussed, and here you can see z0 equal to 1 is the singular point for this function, but z0 equal to 1 is not the singular point of this function. Okay, so how we solved that one? First we calculated the ls of 1 by z minus 1 about z0 equal to 1. That means for this function z0 equal to 1 is the singular point. Okay, and we found the Lorentz series of 1 by z minus 1 about z0 equal to 1. How much? Itself 1 by z minus 1, that we found. These things I told to you that you have to do by yourself, because same thing about function 1 by z minus 1 about z0 equal to 1 here I written. Okay, just previous I written step by step, right? Last class I forgot to tell to you 2-3 important points regarding this question. Here I am going to explain carefully. You have to watch. So first we found the ls of 1 by z about z0 equal to 1. Then we have been calculated the ls of 1 by z about z0 equal to 1. That means the Taylor series of 1 by z about z0 equal to 1. How much we have been found? We found this one, 1 by this one. Finally we found this one, ls of 1 by z about z0 equal to 1 equal this much. Okay, this series is the so-called ls of 1 by z about z0 equal to 1, or ts, Taylor series of 1 by z about z0 equal to 1, this one. In another method also we have been solved the same, right? Finally what we got the answer? Finally we got the answer that ls of 1 by z into z minus 1 about z0 equal to 1 will be equal to what? Will be equal to this much. Okay, that means this function with the help of partial fraction we written this one and this one. The Lorentz series of this one we found the same, that is 1 by z minus 1, and the Lorentz series of 1 by z we found this one. We just subtracted these two, or you can say just added. Okay, that means we written the Lorentz series of this one equal to this much, and Lorentz series of 1 by z, or the so-called Taylor series of 1 by z about z0 equal to 1 is this much. Okay, so finally we got the answer, this one. So the important point here I'm going to tell to you that here you can see, whenever we have been discussed the Lorentz series, may you have been remembered, we found this one. In general, this is the Lorentz series of any function. One is the analytical part and another is your principal part. So in the analytical part we can found z minus z0 to the power n, and in the principal part we can found z minus z0 to the power minus n. So here you just identify here, this is the Lorentz series of this one, no? 1 by z into z minus 1 about z0 equal to 1. What is the Lorentz series? This one. So here you can see which one is the analytic part and which one is the principal part. Principal part having the power in the negative, but analytical part is z minus z0 to the power n, that means positive. Here you can see z minus z0. This one is nothing but your z0 to the power n. So obviously this one is your analytic part, right? Here this one can be written as, this can be written as here 1 into z minus 1 to the power minus 1. So here z minus 1, here 1 is nothing but your z0. So this is your what? Principal part. So here what we have been concluded, that whenever we are going to find out Lorentz series of a function about its singular point, here I'm going to show you that this was the initial function 1 by z into z minus 1, and we are trying to find out the Lorentz series of this function about z0 equal to 1. That means z0 equal to 1 is one of the singular point of this function, right? So here if I'm going to consider entire function, this function has two singular points. One is your z equal to 0, another is your z equal to 1. So here about z equal to 1, when we tried to find out the Lorentz series of this one, then we found this one, analytic part and principal part. Got it? Likewise, if we are going to find out the Lorentz series of this entire function about z equal to 0, also we can found the two part, analytic part and principal part. And here also we concluded that whenever we want to find out the Lorentz series of a function about any one of its singular point, only Taylor series could not be work. That means Lorentz series we have to consider. Okay. So here I forgot to write. This series also can be written in this format. That means ls of 1 by z into z minus 1 about z0 equal to 1 will be equal to here you can write first the analytic part we can write, that is your minus summation over n equal to 0 to infinity minus 1 to the power n z minus z0, here z0 is your 1 to the power n, then plus z minus 1 to the power minus 1. So in this way also we can write this one, right? That means here whenever we trying to find out the Lorentz series about one of its singular point, we can found one is your analytic part, this is analytic part, and this is your principal part. Okay, now we are going to go for our next question, that find the Lorentz series of 1 by z minus 3 about z0 equal to 5. Okay, so let's start. From the question it can be found that here we have to find out Lorentz series of this one by z minus 3 about z0 equal to 5. That means this z0 equal to 5 is not the singular point of this function. That means in the question indirectly it is asked that we have to find out the Taylor series of this function 1 by z minus 3. In the last class we discussed that for here you can say for 1 by z, z0 equal to 1 is not the singular point. How we have to solve or how we have to find the Lorentz series for 1 by z about z0 equal to 1 in detail we have been discussed by this method and also by this method also. Okay, in this question, for this question also we are going to do or we are going to solve its Lorentz series by two method. Okay, see एक दो बार प्रैक्टिस कर लो दो मेथड में, उसके बाद तुम एग्जाम में जो करना है करो, ठीक है? Okay, so I told that whenever we are going to trying to find out the Lorentz series, first we have to draw this figure, right? So for this question first I am going to draw the figure. Okay, so this is the real axis and this is your imaginary axis. Draw the figure according to your question. Okay, so here question is given that z minus 3, that means the singular point of this function exists here somewhere, and about the point where we have to find out the ls also this side. So you just draw the figure to take the larger space this side, okay, smaller space to left hand side. So this will be 1 2 3 4 5 6 and 7. Okay, and this will 1 2 3 4, okay, like that. Okay, ऐसे कर लो. Now where we have to find out here 1 2 3 4 5, here we have to find out the about this point z0 equal to 5. So here z0 equal to 5, about this point we are going to find out this function's Lorentz series, and it's a singular point where it is exist 1 2 3 here it's a singular point exist, that is your so-called singular point or is considered as z dash equal to 3, which is your singular point for this question. So last class we have been discussed that if this type of question has been given, that where we have to find out about the point where we have to find out the Lorentz series, if that point is not belongs to its singular point, then that point also, at that point also this function is analytic. So here you have to from this point the function is going to spread in all the way if this function is going to spread, okay, circular manner. But what it will happen? Exactly at z equal to 3, or so-called z dash will be 3, the function will be interacted, it's a singular point and it could not be spread beyond that. So what will be the circle? It will the circle finally. So this side it will move 2 points, this side will it will move the moved it will be 2 points. So this will be the circle in which we have to find out the Lorentz series. See, this is one type of tricks you can say. This is the one type of tricks you can say. With the help of these tricks, you can easily find out the Lorentz series of this function. Okay. Now, here we found that z dash is your 3, which is your singular point. Beyond that, this function could not be spread. And as this point z0 equal 5 is not the singular point of this function about which we have to find out the Lorentz series, so from there, from that point, it will spread and it will interact with its singular point. Beyond that, वो स्प्रेड नहीं कर पाएगा. तो कितना बड़ा सर्कल बनेगा? इतना बड़ा सर्कल बनेगा. अभी ये जो पॉइंट है, दिस पॉइंट विल बी ट्रीटेड एज z dash and this point is your z0. So inside this, the function is fully, this function 1 by z minus 3 is fully analytic. So what we have to find out? We have to move from this point. This is the outside point considered as z dash. So from this point, we have to move any one of the point z inside this region. So what we are doing here? We are doing here out to in. Okay, we are doing here out to in. So we have to apply the out to in formula. What is the out to in formula? This one, 1 by z dash minus z0 minus z minus 0 z0, and into out factor could not be come for this case, because here this z0 about which we are trying to find out the Lorentz series, this function is not the singular point. So C2 not come into the picture. So यहाँ पे C2 नहीं आएगा, क्योंकि C2 वहाँ पे आ रहा था, इसीलिए कि Z0 वहाँ पे सिंगुलर पॉइंट था. अभी C2 ये जो Z0 है जिसके और हमको लेना है लॉरेंट सीरीज, वो सिंगुलर पॉइंट है नहीं. यहाँ पे भी फंक्शन एनालिटिक है, और इनसाइड दिस सर्कल एट ऑल द पॉइंट ऑल्सो फंक्शन इज एनालिटिक. सो C2 यहाँ पे आएगा ही नहीं, सिर्फ द सो कॉल्ड C1 ही आएगा. सो हियर C1 ही आएगा, C2 आएगा नहीं. ठीक है. सो इन जनरल वी नो दैट what we know that the Lorentz series of the function is your f1z plus f2z. f2z is for the C2 circle, f1z is for your C1 circle. f2z could not be found over here for this case because C2 आएगा नहीं. C2 circle, the inner circle could not become for this case. So only f1z आएगा, और f1z को हमको सॉल्व करना पड़ेगा. जितना आएगा, जो आएगा वही हमारा आंसर ही होगा. That will be our answer. Okay. Similar manner we have to write. So in the last class, all the step I have been written over here. So once again, all the steps I'm writing for this question. But I suggest to all of you that whenever you are going to do in the exam, do not write all the steps. Direct you have to write from here. Okay. From here you have to write for your exam. Okay. But for this question, I have to write all the steps. Carefully watch and write your note. Here in this case, z0 equal to 5, which is not the singular point of the function of the function 1 by z minus 3, right? But singular point of 1 by z minus 3 is at where z equal to 3. Okay. Now we know that ls of a function fz is equal to f1z plus f2z, right? But f2z will be equal to 0 for this case, because C2 is not to be considered. not to be considered. Okay. Okay. Now अतएव ls of fz at about z0 equal to 5 will be only the so-called f1z. Right, now we are going to find out the f1z only. So just write finding the f1, finding the f1z. So for f1z, what we have to write, same steps I'm writing over here. For f1z, this is the case of out to in case, out to in. So for out to in general, we have to write for out to in general, what we have to write, one, sorry, this is your fz. This is the denominator of given function. Okay, in general, the denominator of given function will be, what we have to write, 1 by z dash minus z0 minus z minus z0. Right, our given function is your 1 by z minus 3. There is there is no factor of on the numerator में कुछ है नहीं. So for this case, what we have to write, that implies 1 by z minus 3. What we have to write, 1 by z dash, here in this format we have to write z dash minus z0 minus z minus z0. For this case, z0 is your 5 and z dash is your 3. So that implies 1 by z minus 3 will be equal to, written as 1 by z dash is your 3 minus z0 is your 5 minus z minus z0 equal to 5. So I told that up to this much you have to write. Then here you have to consider the important point. Here I written that match the denominator with this one, or match the entire function, that is it matching with the initial one or not. If it is matching, then okay. If it is not matching, then you have to put the minus sign. Okay, so here we found 1 by z minus 3 is equal to 1 by 3 minus 5 minus z minus 5. Now you just match that this one is equal to this one or not. What you have to do, you to match this, you just take your rough. Don't open this bracket, z minus 5 bracket you do not open. This z minus 5 bracket don't open. Okay, so here we have what, 3 minus z, sorry, 3 minus 5 minus z minus 5, no. So this will be 3 minus 5 is your how much, minus 2. This is your minus z plus 5 plus 5. This will be how much, minus z plus 3. If I will take common minus, then it will be z minus 3. So if I will compare this one with this one, so this is what we found. We found 1 by minus z minus 3, but actual function is your 1 by z minus 3. But here we found 1 by minus of z minus 3. So it is not matched. It is not matched. What we have to do? We have to just multiply 1 minus over here. Got it? Okay. Up to this you have to write by considering this general formula, out to in, considering out to in. If it will be matched with the original function, then no problem. If it is not matched, then you just multiply minus 1. Now this right hand side is exactly matched with the left hand side. Okay, so now Lorentz series of 1 by z minus 3, or f1z, you can say f1z about z equal to 5, z0 equal to 5 will be equal to how much? Here you can say minus 1 by here 3 minus 5 will be how much? Minus 2. I told that this bracket you should not open, z minus 5. Okay, okay. Now here you can see minus 1 divided by, take minus 2 common from this term and this term. I told that whatever the first term will be, here first term is your minus 2, take common blindly. Okay, minus 2 taken common, we found 1 plus z minus 5 by 2. Got it? Okay, so that implies Lorentz series of 1 by z minus 3, or we are trying to find out the f1z. So will be equal to, here minus minus got cancel, and we found 1 by 2 into 1 plus z minus 5 by 2, or this can be written as 1 by 2 into 1 by 1 plus z minus 5 by 2. Okay, z minus 5 by 2. So here you can see that z minus 5 by 2 is always less than that of the 1. You can see z means any point inside this circle. Inside the circle, consider this one. This point value is how much? This point value is 4. If this is 3, this is your 4. Okay, so you just take 4 minus 5 is how much? 4 minus 5 is your minus 1 by 2 is less than 1. Now consider this one, 6. So if I am going to consider the point 6, so 6 minus 5 is your 1 by 2, also less than 1. If I take this one, just above the 3, just above the 3, see this circle will be just touch the singular point. ये singular point को touch नहीं करेगा, ये singular point के पास देके जाएगा. Okay, so here this is the boundary will be just above the singular point. That means 3.00001 you can say. Okay, so 3.1, suppose you consider this point here, this point you consider the 3.1. So here 3.1 minus 5, if I am going to consider 3.1 minus 5, then what it will be? 3.1 minus 5 by 2 will be how much? That will be 1.9 by 2 minus 1.9 by 2. The magnitude is how much? Less than 1, yes or no? So here automatically we found this term is less than 1, and we know that the expansion of 1 by z, or we can write 1 by z plus z minus 0, that means expansion of 1 by 1 plus z about 0 is equal to how much? Minus 1 to the power n summation over n equal to 0 to infinity minus 1 to the n z to the power n. Okay, now yes, this, the expansion of this one will be this one. The condition is that z is always less than 1. These things already we have been discussed in our Taylor series. Okay, so if we are going to apply same situation for this case, here you can see 1 by 1 plus some function z which is less than 1, then expansion is this one. So if instead of z we have z minus 5 by 2, then instead of z we have to write just z minus 5 by 2 to the power n. Simple, right? Now we are going to do so. That implies Lorentz series of 1 by z minus 3 will be equal to 1 by 2. This one will be written as summation over n equal to 0 to infinity minus 1 to the power n into this one z minus 5 by 2 to the power n. So this is the Lorentz series of this function about z0 equal to 5. Because here f2 we are no need to find out, f2 यहाँ पे तो निकलना नहीं है. So Lorentz series क्या होगा? Only जो f1z निकलेगा. यहाँ पे f1z क्या निकला? इतना. Okay, so Lorentz series of this one about z0 equal to 5 equal to this much. Okay, now we are going to find out the Lorentz series by another method of this function. Okay, of this function by another method, by this method. By other method what we have been discussed for this function in our last class. Okay, so you just write other method. See, I suggest that you just do by two method. Remember the two method, but this method is always useful because here we are using the concept. How we are using the concept, now I am going to explain. You just wait. To find LS of 1 by z minus 3 about z0 equal to 5, right? So here what we have to do, the about z0 equal to 5. So here in the question, z0 equal to 5 is not the singular point of 1 by z minus 3. So that means what? Indirectly z minus 3. Indirectly question asks that we have to find out the Taylor series of this function about z0 equal to 5. That here you have to write that indirectly we have to find out, or the question asked the question asks to find the Taylor series TS of 1 by z minus 3 about z0 equal to 5. So how we have to do that? Here you can see Taylor series of 1 by z minus 3 about z0 equal to 5. What we done that here, where is the z? We have to write z minus 5 first, z minus 5. Okay, then we have to compare this function, this denominator, that is it matched? It is not matched because it is z minus 5 and z minus 3. What we have to do that it will be minus 3. That means what I have to do with this numerator, then it will be z minus 3. What we have to do? If I'll add the plus 2, okay, here you can see 2 minus 5 is nothing but minus 3, z minus 3. Now it is matched. Okay, so here 2 taken common from these two terms, that is 1 by 2 taken outside, 1 plus z minus 5 by 2. Here z minus 5 by 2 is less than 1, so TS of 1 by z minus 3 about z0 equal to 5 will be equal to 1 by 2 summation over n equal to 0 to infinity minus 1 to the power n into z minus 5 by 2 whole to the power n. Okay, this one is nothing but this one. So here you can see that by this method we retain so much things. Maybe you are thinking that इस मेथड में तो बहुत सारी चीज़ लिखना पड़ता है और इस मेथड में तो 2-3 स्टेप में हो जाता है. See, here you can see that why we are going to consider 2 here. So how this 2 came, where this 2 came? Here we just adjusted that z minus 5 लिखने के बाद we have to write 2 to equalize the denominator, but this 2 here we written to adjust it one, this one. But how this 2 came? This is the theoretical explanation. Automatically this 2 will become, this 2 automatically it will become if we are going to follow the Lorentz series method, because this is the procedure, actual procedure what we have been studied in the theorem, in the Lorentz series theorem. Only for that I suggest you just write this way in your note, practice this way, because this way is the actual way and this way is your the so-called shortcut way. Because why I am telling that you have to remember this way, because sometimes we are going to do some questions in our next videos. Sometimes what I have to take common from these two term, it will be confusion. वो कंफ्यूज होगा कि क्या मैं कॉमन लूँ. तो उस वक्त अगर इस मेथड में तुम करोगे, अगर किए होगे इस मेथड में, तो देयर इज नो कंफ्यूजन. व्हाट विल बी द, आई टोल्ड, व्हाट विल बी द फर्स्ट टर्म, नो, व्हाट विल द फर्स्ट टर्म दैट यू ब्लाइंडली टेक द कॉमन from these two terms, automatically answer you can found. Got it? Okay, now we are going to go for another question. Here the next question is your question number 3, that we have to find out Lorentz series of the function 1 by 5 minus z about z equal to 7. So from the question it can be clearly found that we have to find out the Lorentz series of a function about a point which is not its singular point, because if I am going to consider this function, the singular point of this function is your 5. So we have to find out the Lorentz series about z equal to 7. That means according to the question indirectly asks that we have to find out it's a Taylor series. That means this question is very similar with this question. Okay, actually this is your question number 4, mistakenly written. This is your question number 4, question number 4. It is very similar with question number 3. Okay, so here I am going to give you the just the hints that how you are going to draw the figure, because I told that this figure is most important, and then you just solve this question number 4 how we have been solved this question number 3. Okay, so this is the entire complex plane. Here this is the 1 2 3 4 5 6 7. So this is the z equal to 7, means about this point we have to find out the Lorentz series. That means this is our z0, and singular point of this function is your 5. 5 means here 1 2 3 4 5. Here this is the singular point that is your 5, and this will be your z dash. That means this z equal to 7. That means at z equal to 7, this function is analytic. Only at z equal to 5, this function not to be analytic. If I will put 5 over here, then this will be 1 by 0 will be equal to infinite, could not be defined. So hence z equal to 5, this point is your singular point. So what is the tricks or procedure? That means here from this point where we have to find out the Lorentz series, from there the function is going to be spread uniformly along all the way. Circular manner, you just think circular manner. So if it is so, then it will interact just before or with its singular point. That means at the singular point this could not be defined. So just below the singular point, or you can say at singular point, this spreading is going to stop. See, this procedure what I am here explaining, that this spread it will be stop at this singular point. This is a simple tricks I am telling you. Only tricks. You cannot find any book. So this is the method which follow the theorem, Lorentz theorem. Okay. So here this point is your z equal 7, which is not its singular point. So if it will spread all the way here 1 point 1 point, likewise this side 1 point 1 point, and this 7 8 9 up to 9 it will move towards right, up to 5, just before 5 it will stop. It's spreading. So this is the region we found. Any region z, in the inside this region, any point, arbitrary point, we have to consider z. So if I will move from this z dash to z point, what is the procedure? Here out to in. So here out to in, and as inner point is not the singular point, so C2 we are not going to consider over here. C2 we are not going to consider, and we are going to consider C1. So for any function corresponding Lorentz series will be written as f1z for C1, f2z for C2. So here C2 we are not going to consider, means f2z will be 0. This question is very similar with the question number 3. So all the step I'm not writing here. Here I'm giving the only hints. You just write step by step. Okay. So if out to in will be considered, then 1 by 5 minus z will be written in this format, that z dash minus z0 minus z minus z0. So here z0 is your 7, z dash is your 5. So 1 by 5 minus z will be written as 1 by z dash will be how much? 5 minus z0 is 7 minus z minus 7. Okay, up to this much you have to draw, you have to do like this. Then you have to check that this denominator is exactly matched with our original function or not. Most important, or this entire function. See, here we change the denominator, so you just check the denominator is matching with this original function or not, or original denominator not. So you just do it in rough. This is your 5 minus 7, that is your minus 2, here minus z and plus 7. So what we can get? We can get minus z plus 5. So if I'll take common minus, then z minus here z minus 5 we can get. But our original function is 5 minus z. That means if I will multiply a minus with this one, then we can get, wait, here I done mistake, that here you can see that if I will calculate the denominator, we can find the same. Here minus z plus 5, that means 5 minus z, right? Again you just check, this will be minus 2, this will minus plus 7, so it will minus z plus 5. That means this is correctly written. So if I will match with this with original, it is exactly matched. So we no need to here multiply the minus, right? Now what we have to do? So 5 by 5 minus z will be equal to here 1 by, this will be minus 2 minus z minus 7. I told that you don't open this bracket. This is most important. Don't open this bracket. 1 by, here first term is your minus 2. You just take common minus 2. It will be 1 plus z minus 7 by 2. So here we can find that 1 by minus 2 into 1 by 1 plus z minus 7 by 2. Here z minus 7 by 2 is less than 1. Automatically it will be happen. You should not be bothered about that. Automatically this will be less than 1. You can check from this figure. you can check from this figure that any value z, if you are going to consider, suppose you are going to consider just above the c, this circle is not going to touch the 5. That means this circle is just above the 5. That means 5.1 you can consider this one. This point is a 5.1. So z minus 5.1 will be how much? Z is your 5.1, right? 5.1 minus 7 will be how much? Will be 1.9. 1.9 by 2 is less than 1. Here you consider this will not this will 9 or 8.9 suppose. So 8.9 minus 7 by 2 will be how much? 8.9 means it will be how much? 1.9 by 2. That means less than 1. Here this will be minus 1.9. But if I am going to consider magnitudically, so it will be less than 1. So what we got that inside this bracket, the factor is always less than 1. Now we can apply this one. 1 by 1 plus x expansion. We know that if x is less than 1, this expansion is your n equal to 0 to infinity minus 1 to the n x to the power n. So here for this case it will be minus 1 by 2 already is there. So expansion of this one will be n equal to 0 to infinity minus 1 to the n z minus 7 by 2 to the power n. So this will be its Laurent series. By another method, the so-called Taylor series also you can found. So this is the procedure. Already I explained all the steps, but you just write systematically as I explained in the question number 3. Now we are going to go for our next question. Is your question number, this one, question number 5 it was. This question number 5. 6. Okay, question number 5. Here you can see in the question number 5, it has been asked that we have to find out the Laurent series of 1 by z plus 5 about z equal to 7. So here you can see for this function, singular point is your minus 5, but we need to find out the Laurent series about z equal to 7, or we can say z0 equal to 7. That means according to the question, indirectly it is asked that we have to find out it's a Taylor series. So you just draw the figure first. Draw the figure. This is the complex plane. 1 2 3 4 5 6 7 8 9 10 1 2 minus 1 minus 3 minus 4 minus 5 minus 6 minus 7 minus 8 minus 9 minus 10, like this, because singular point exists at minus 5. 1, this is 0, z equal to 0, 1 2 3 4 5. So this is the singular point minus 5, and this will be our z dash. Okay, but where is the z0? Z0 is at 7, means 1 2 3 4 5 6 7. This is your what? Z0 equal to 7. So here we have to find out about this point. We have to find out the Laurent series. Okay, so here you can see this point is not the singular point of this function. So at this point this function can be analytic, but at exactly at minus 5 this function not to be exist or not analytic, because if I will put z equal to minus 5 here, this will be denominator will be 0 and the function will be infinite. So except z equal to minus 5, the function exists everywhere inside this in the complex plane. So here if this is not the singular point, so at this point analytic, at this point only, except this point not to analytic. So the function will spread from here. It will start spreading here equally in all the way. So its boundary is going to increase, and when it will just interact with minus 5, just before minus 5, its spreading is going to be stopped. Okay, this is, I told several times, this is the simple tricks to find the Laurent series, and these tricks followed the theorem itself. Okay, so here z dash is your minus 5. That means you are standing over here, and any point z inside this region we are going to consider. That means if we are going to move from this point to this point, that means we are moving out to in. So for this case we have to consider out to in, and here C2 is not going to be considered. So C2 is not going to be considered, so corresponding F2 will be 0, and this region, this circle is your so-called C1, so only F1 is going to be considered. So FZ Laurent series will be your only f1z, right? That belongs to C1. So f1z, for f1z, here we have to consider what? Into out case. Out to in case. Out to in case means the given function 1 by z plus 5. 1 by z plus 5, the denominator will be written as in this format: z dash minus z0 minus z minus z0. So here, for this case, z dash is your minus 5, z0 is your 7, 7. So minus 7 minus z minus 7, right? Now we are going to check this denominator value is exactly matched with our original function's denominator or not. If not, then we have to multiply another minus. If matched, then no need to multiply. That means we retain this function corresponding denominator in this style. That's it. Okay, in this style. Now you just check that this denominator is exactly same with this one or not. Here I told that you don't open this bracket, you just in the rough you just calculate. Here you can say minus 5 minus 7, this will be minus 12 minus z, this will be plus 7. So this will be minus 12 plus minus 5 minus z, take minus common, this will be 5 plus z or z plus 5. That means it is not matched. This is not matched. The denominator is the negative. In negative situation is there. So you just multiply minus 1. That means this function designed in this way. Got it? Designed in this way. Same thing. Whatever here written, same thing it is written over here. 1 by z minus z plus 5 designed this way. Considering C1, C2, blah 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 blah, whatever the theorem we have been discussed, everything we have been considered, and we designed 1 by z plus 5 in this format, right? Then what is our next step? Next step is your, first we have to write minus 1, this one is your minus 12, right? 7 plus minus 12 minus z minus 7. So what is the first term? Minus 12, we just take common from these two terms. This will minus 1 minus 12 I taken common, so this will 1 plus z minus 7 by 12. Got it? Okay, so here we found 1 by 12, 1 by 12, 1 by 1 plus z minus 7 by 12. So here you can see z minus 7 by 12. For this case, if you are going to calculate for this figure, always this value this value will be less than 1. So if it is less than 1, then we can apply this one, that 1 by x, 1 by 1 plus x. If x is less than 1, the expansion will be this one. So for this case, expansion will be how much? This one. Already 1 by 12 is there, and this will be n equal to 0 to infinity minus 1 to the power n z minus 7 by 12 to the power n. Okay, so this is the Lorentz series of this function 1 by z plus 5 about z0 equal to 7. Got it? Okay. Now we are going to consider next question, that is a question number 6. Find the Lorentz series 1 by z plus 5 about z equal to minus 7. Here you can see this is the same situation. For this function, z equal to minus 5 is the singular point, but we have to find out Lorentz series about minus 7, which is not the singular point of this function. That means indirectly it is asked that we have to find out the Taylor series. So if I am going to draw the figure, that means the 1 2 3 4 5 6 7, so minus 1 minus 2 minus 3 minus 4 minus 5 6 7 8 9 1 2 3 4 5 6 7. This is the minus 7, z equal to minus 7, about which we have to find out the Lorentz series. That means this is also z0. And where is the singular point exist? Singular point exists at minus 5. 1 2 3 4, this one minus 5. So this is your singular point, that is your z dash, it will be. That means this point is not the singular point, so function is going to be spread in all the way. So when it will just interact the minus 5, it will stop. That means this is the our required region. So this side 2 step it will move, this side also 2 step. That means up to this much. This is the 7 now. Minus it, just before minus 9 it will stop. Just before minus 5 it will stop. Got it? Now, so here where you are here. any point inside this circle means the situation is your, if we are going to move from this point to inside, that means out to in situation. So 1 by z plus 5 will be written as in the form of z dash minus z0, because out to in means what, z dash minus z0 minus z minus z0, and here z dash is minus 5, you just put it. 1 by z dash is your minus 5, z0 is your minus 7, right, minus z minus z0 is minus 7, so it will be plus 7. Okay, got it. Now you have to check this value and this value is same or not. Here you can see roughly you have to check minus 5 minus 7. Sorry, here I done a mistake. Here z dash minus z0, z dash minus z0 means minus 7, so this will be plus, right? Now we have to check that this denominator or this entire function what we written is exactly same or not. Here you can see minus 5 plus 7, it will be 2 minus z minus 7 minus z minus 7, because here is the minus, so here we got minus z minus 5, that means minus of z plus 5, minus of z plus 5, but our original function is 1 by z plus 5. Here minus came, so we have to multiply minus. Got it? Okay, so this will be minus, and I told that this bracket do not open, and what will be this factor, you just take common. So this factor will be 2 minus z plus 7. Got it? Okay, so it will be minus 1 taken 2 common, it will be whatever this first factor, whatever you just take common. 2 if I take common, this will 1 minus z plus 7 by 2, right? Okay, so here minus 1 by 2 and 1 by 1 by 1 minus z plus 7 by 2. Okay, so here you can check that z plus 7 by 2, any value of z, you just take, and plus 7 you consider divided by 2, always less than that of the 1, you just check. Suppose I am going to consider this point. See, this point means it is just below the minus 5. That means if this point is your minus 5, this point is your minus 5.1, you can consider this point is your minus 5.1. So here I am going to consider minus 5.1 plus 7, so it will be what, it will be 1.9, 1.9 divided by 2, less than 1, 9. Okay, so here this point I am going to consider is just this side of minus 9, that means minus 8.9 you can consider. So minus 8.9 plus 7 by 2 will be how much, will be 1.9 minus 1.9 by 2, magnitudically less than 1, so this value will be always less than 1. So we know that if 1 by 1 plus x, sorry, 1 by 1 minus x, okay, 1 by 1 minus x situation is there and x is less than 1, then it's a series or Taylor series about z equal to 0 is nothing but summation over n equal to 0 to infinity x to the power n. You just compare this one with this one. Instead of x, what we have, z plus 7 by 2. So what will be the answer here? ls of 1 by z plus 5 about z equal to minus 7 will be equal to minus 1 by 2 into this one. This value will be what? Summation over n equal to 0 to infinity z plus 7 by 2 to the power n. So this is the answer. See, here I done all of these steps, but systematically you have to write in your note. Systematically you have to write in your note like this. You can omit 1 or 2 steps, but clearly systematically you have to do these 3 questions, question number 4, 5 and 6. Okay, now next class we are going to go for another type of question. No, before that I am going to give you another question, that find out the Lorentz series of 1 by 5 minus z into z plus 5 about z equal to 5. So if you are going to consider this function, entire function, here z equal to 5 is one of the singular point. Z equal to 5, here you can see, if I will put z over here, z equal to 5 over here, this will be 0, but this factor is not going to be 0, this factor will be 0. That means if I am going to consider this entire function, its singular points are, one is your 5 here, from this 5, and from this we can find minus 5. So in the question it has been asked that we have to find out the Lorentz series about z equal to 5. That means at last we can find a principal part and analytic part. So this question entirely, I'm not going to hints, I'm not going to give any type of hints, but here I'm going to tell to you that first you do the partial fraction. This one, do the partial fraction. If you are going to do the partial fraction, you can get 1 by 5 minus z. You just do it in a rough. Z plus 5 will be equal to 1 by 10 into 1 by 5 minus z plus 1 by z plus 5. You just add it. It will be z plus 5 plus 5 minus z. So minus plus z got cancelled. So numerator will 10. I divided 10. So this will be the. So here we got the two terms. One is your 1 by 10 into 1 by 5 minus z plus 1 by 10 into 1 by z plus 5. So first we have to find out the Lorentz series of this one, and we have to find out the Lorentz series of this one. Here you can see Lorentz series of entire function, where we have to find out about z equal to 5. So if I'm going to consider this one, so here, that means if I'm going to consider that, only this function is given, and we have to find out the Lorentz series about z equal to 5. That means about its singular point it has been given. So for this one, about its singular point we have to find out. If we are going to follow the steps, that means we have to draw the figure. So 5 will be here somewhere. So here we are going to consider c2, then c1, and for that you have to consider f1z, then f2z, and the f1z will be 0. F2z, if we are going to consider, then the value will be how much? Same, 1 by 5 minus z you are going to get. So finally you can get 1 by 10, 1 by 5 minus z. So the Lorentz series of this one about z equal to 5, that means about its singular point, you can found itself. Okay, now the Lorentz series of this one, about z equal to 5, that means here for this case its singular point is what? Minus 5. But we have to find out the Lorentz series about z equal to 5. Z equal to 5. That means if I'm going to draw the figure 1, 2, 3, 4, 5, here we have to find out about this point. This is the 5, no? So this is the 5. About this point we have to find out the Lorentz series, but its singular point is exists at minus 5. So this will spread, and this will spread up to this much. That means the so-called Taylor series we have to find out of this one. 1 by z plus 5 about z equal 5. Similar type of question we have been done here. 1 by z plus 5 about z equal 7. Okay, likewise we have to find out 1 by z plus 5 Lorentz series about z equal to 5, which is not its a singular point, because singular point will be at minus 5. Here is the z dash. So if I'm going to do then we can found its analytic part. That means in the form of like this, summation over z minus, here z minus 5 by something to the power n. Okay, and here this is your principal part. Principal part means 1 by 10th is there, so this can be written as 5 minus z to the power minus 1. So if I'm going to add both, this will be final. This type of answer you can get. This will be your principal part, okay, and this will be your analytic part. This question I will be discussing in the next class, but I suggest that you just do it by yourself in detail. Don't leave any step what we have been discussed. See, this question is exactly similar with this one. Here you can see this question here, 1 by z into z minus 1 about z0 equal to 1 means about z0 equal to 1. Here for this case there are two singular points, one is 0 and another is 1. So one of the singular point we have to find out the Lorentz series. Finally we found this one. This one. Okay, this is your principal part, this is your analytic part. Here I written once again. So what are the procedure or steps I have been followed for this question? No, I saw this that you just follow for this question. Little bit step you can omit, but clearly draw the figure and do it. And this question especially I am going to discuss in the next class. Okay, and next class we are going to discuss this question. This is another type of question. That means here find the Lorentz series of the function 1 by z minus 2 into z minus 3 between annular region z equal to 2 and z equal to 3. Okay, annular region means here it is not given that about which point we have to find out the Lorentz series, but annular region z equal to 3, two radius given of two circles. That means 1, 2, 3. Okay, 1, 2, 3. So this will be one region having the radius is 2, and this is another region having the radius is what? 3. This is the 2 point, 3 point. So this is the point. That means about z0 equal to 0, we have to find out the Lorentz series. So here Z0 is not given. Z0 is inherently is there in this figure, in this question. Z0 is your 0 and annular region means this one. In between, in this region, considering we have to find out the Lorentz series of this function in this region. Okay, in detail we are going to discuss in the next class. Thank you so much for watching this video. Thank you.